welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Shawn Varney.
Thanks, Will. Hi, everybody. So this week we're going to be talking about drying challenges for metal finishing on our Tech to Tech. So the topics we're going to cover here is kind of 5 categories. We're going to talk about the importance of drying your parts, challenges of aqueous-based chemistries, challenges for solvent-based chemistries, machine type and limitations of that, and the environmental impact with drying, what you got going on. So first one is, why is drying important? First thing that comes to mind is rust. You don't want rust on your parts, or customers don't want to see that. It can affect your processes and whatnot, right? So another point here would be moisture from not drying the parts could start a corrosion. Rust and corrosion is not good. We don't need those on the parts. Drying is very important to stay away from this. Could be important for the next step, the next stage of the production. And it could affect that process. Like, it could affect maybe a coating process, whether that is, painting. It could be powder coating. You could have a CP or RP, which is corrosion preventative or rust preventative protection kind of products that go on there. You could have stickers or labels that are going on that could affect your adhesion on there, and you don't want them to peel off. So drying is very important when you get to those kind of steps. Yeah, and big thing is, you don't want to leave water spots for the customer to see, even though it might not have any necessarily problems with the parts, but your quality team or the customer might like those water spots and go from there to take those off. Challenges for aqueous-based chemistries, flash rusting is a big thing for, aqueous-based. You could have longer drying times, which leads to higher temperatures. So to dry, you would need, air knives or blowers, and those need to be heated to those higher temperatures. These higher temperatures could increase, energy consumption. Energy consumption can affect, the cost overall. Aqueous may require baking of the part after, being washed. So maybe it didn't get fully dried through that air knife or blower or whatnot. So now you want to bake the part in an oven to get the hard to reach areas. You can also use maybe a better style process for drying. It's called vacuum drying. It's a little more expensive, but it just means you'd have another process to add onto there with some aqueous. There's some challenges for drying. Some parts can't come in contact with just water and can't get wet, and they need to go towards the solvent route application. With aqueous, importance of the machine setup becomes very critical too as well. You want to check your process. Exhaust, let's just say you're drying it through an inline cleaner or batch cleaner or whatever you might have, but the exhaust isn't good enough and it's not pulling that moisture out as you're baking it. You want to be pulling that moisture out through the exhaust. You could have spray pressures that are too high and reaching components that you didn't want to get water in those areas. Directions and nozzles, you only want to kind of clean at the areas you want to. You don't want to spray into parts, just like spray pressures, where you don't want it. There's a lot to the process. Checking it, those are just a few key areas, but machine setup becomes critical on aqueous to make sure you're not affecting one other aspect of it. So I bring up how clean is your water, and I'll give you an example of this. I had a customer that we had a tank-to-tank style dip process for cleaning, and we tried cleaning with city water, RO water, and DI water, and it made a big difference on how the drying process was affected. So when we did city water, it's a lower quality, has higher impurities. We saw a lot of spots on there, calcium and whatnot. When we went through the dip process and did in the dip tanks with chemistry and RO water, we saw a little better quality, less spotting, little faster drying. When we went to DI water, we had the best quality water, right? Lower impurities. And then we had our best drying with no spots and whatnot. So water quality can play a big role on your drying process too as well. So challenges for solvent-based now. We just did aqueous, now we're going to do solvent. Solvent, well, it flashes off quicker, does dry, and does a little better in drying, right? But if there's any kind of contamination, it will show on the product before you have time to wipe it off to do a final wipe. So that can be a plus that it dries a little faster, but a minus that you might not be able to do a spot wipe here and there as you see it. Could impact operating cost and higher evaporation rate of the chemistry, but again, it's easier. So you got to watch your evaporation rate. It makes it easier to dry, but chemistry can be on more higher costs. So you want to watch that you're not just wasting it either. There's limited machines that can really use solvents efficiently, but when you pair them correctly and get that process in there, you could save more money and time when you get down to it, when you pair those machines with your process right and you have it all dialed in. So don't be scared of higher cost for a solvent than an aqueous, because they do have a little bit better machines. Depends on your application, right? So pick the right machine and for the process, it makes it drying easier. Overloading of baskets usually is what happens in solvent lines because they think it can clean better. It shields the other parts from getting dry, whether that's deionized or it could be a different type of system, like a vacuum vapor degreaser, overloading parts and whatnot. Chilling zones versus heated zones need to have a good temperature differential. For example, a vapor degreaser tends to have hot fluid and boiling sumps that you'll dip in, and then you'll come up into a freeboard cooling zone, which causes moisture to condensate and rinses the parts. If you don't have that temperature differentials, that two temperatures actually is what causing the drying to happen. So that can be a challenge of the solvent line. Maintenance on the machines can be a little more critical, as you have those temperature differentials for vacuum vapor degreasers, overloading parts in the baskets. They could have a vacuum leak, the vapor zones, and a vapor degreaser. So they tend to be a little more complex on these type of machines for drying. What type of machines do you have in the limitations, right? So there's several different machines when you get to this. There's tank-to-tank style dip systems, like I talked about earlier, or ultrasonics. Really, with tank-to-tanks, cross-contamination can be a problem as you get to the rinse, and after rinse, you dry, right? So that could leave residues as the rinse section gets more contaminated. Your drying is going to leave some spots on, possibly. Ultrasonics-wise, different frequencies, you want to match that for your contaminants and your parts, but it might not remove all your soils, as it doesn't have the best style cleaning for agitation-wise. Another style, spray and air. So, moisture can get under parts. We talked about spray pressures, which can lead to drying challenges with the spray and air machines like a batch washer or an inline washer. There's vapor degreasers. Vapor degreasers need that dwell time in that freeboard area to condensate to dry the parts. Vacuum vapor degreasers. We talked about a little bit of overloading parts in the baskets or not pulling enough vacuum. Those can be some challenges because you're just trying to speed up the process. You don't want to take time away from those because that affects your drying aspect. Does your environment play a role in this? Absolutely. So when you get into temperature controlled facilities, right, that is your best for lowering humidity. Lowering humidity equals faster drying. It's as simple as that, right? Is your operation inside a building or is it outside of a building? Is the sun hitting your parts? Are you in the shade? There's a lot of aspects to that, where you're cleaning these parts, and if you use an aqueous or a solvent, which one's better for those type of applications, because it may dry too quickly and you don't have enough time to clean the part. Packing your bags, if you put these in hermetically sealed bags after cleaning or just loose bags for the customers, whatnot, it becomes a crucial role because you could have very clean, non-spotting parts, but you created a problem because you put in a bag that was wet, or you had a really dry part that was hot and you put that hot part into a bag. Well, that's not good either because then it will just condensate the moisture inside the air, inside the bag, and then leave spots. So it's very important that it's 100% dry and at room temperature before you bag your parts. Big thing is where you live, where you're located, right? So do you live in a northern climate? Do you live in a southern climate? The south tends to be more moisture in the air, where the north tends to be a little drier. The south tends to have a little hotter temperatures, and the north tends to be a little cooler. So whether you're going to flash rush faster or slower and dry your parts, that becomes a big thing of where you're at. Last thing I have for you guys is really frequently asked questions on this topic. So what if I see rust on my product after drying? Well, it's not the end of the world, right? The best thing would be to fix your drying process, see why it didn't dry, and then run it back through the wash. And as it goes back through the drying, you should be good to go. You can just keep on going from there. Not the end of the world there. Question 2, can higher temperatures provide better drying or more challenges? Well, higher temperatures, you would think dry faster, right? But you want to watch your actual material that you're washing, whether it's brass, aluminum, copper, or even steel. All of those can turn colors at the end of the day with too hot of temperatures. So just watch your temperature so that as you're trying to get better drying, but you don't want to discolor your parts. Question 3, how can I improve my drying process? Really, the easiest advice I have for this is go through it step by step. You can work with your machine manufacturer, you can work with your chemistry provider like us, KYZEN, and we'd be more than happy to kind of go through that process, break it down step by step, and see where your challenge is for drying, because it might not necessarily always be the air knife or blower or temperature related. So that's really everything I have for you guys today. Thanks for joining our Tech to Tech, and I'll give it back to William. Thank you.
Thanks, Shawn, and thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.